gentlemen, we're going to take a look at continue to operate with radicals. And now what we're going to do is we're going to add and subtract these radical expressions. So we're going to have to take a look at not just the properties of radicals, but some of the rules that we have from when we want to do addition and subtraction. What we have to think of here is that in order to add or subtract radicals, they must be what we call like terms. Okay? So like terms have the same number underneath the radical. So for example, 3 square roots of 5 plus 7 square roots of 5, we would be able to call 10 square roots of 5 because we have that square root of 5 that we're combining together. Yet 2 square roots of 6 plus 3 square roots of 7 cannot be combined together. The number under the radical has to be the same. So in order to do this addition and subtraction, what we're going to have to do is simplify each radical first, then combine the like terms. So if we take a look at example 1, we have 4 square roots of 3 plus 2 square roots of 7 minus 9 square roots of 3. I know these radicals aren't going to simplify because they're prime numbers. And so what I'm going to do from there is combine the like terms. The 4 square roots of 3 are going to be combined with the subtracting 9 square roots of 3 with the negative 9 square roots of 3. So when I do 4 minus 9, I get a negative 5 square roots of 3. I still have this middle term here, so it just gets added on at the end as plus 2 square roots of 7. If we take a look at number 2, we have 3 square roots of 5 minus square root of 20. Now, as we were working through these over the past couple of days, we pretty much could start simplifying our radicals with any pair. But when I'm doing the addition and subtraction, I really want to think smart about how I start those. If this is 3 square roots of 5, I really want this to end up with a square root of 5. So I'm going to start this not at 2 and 10, but I'm going to start it at 5 and 4. So now I know I have a 5, or possibly have a 5 under my radical. I'm going to simplify the 4 down to 2 and 2. So when we take a look at it, this radical simplifies down to 2 square roots of 5. This one was already in simplest form, so we have 3 square roots of 5. So I'm going to do 3 square roots of 5 minus 2 square roots of 5. You can call that 1 square root of 5, or you can simply call it square root of 5. All right, ladies and gentlemen, you have a couple of on your own. We can pause the video here while you guys work. And then I'll go through and do the examples. So square root of 2 is already prime, so we know we're done there. So I'm going to call this 2 times 25. The 2 is prime, so the 25 is broken down into 5 and 5. We should have 5 square roots of 2. This is 6 square roots of 2, and it says that we're adding those together. So we should have 11 square roots of 2. When we take a look at letter B, we have 8 square roots of 7 minus 2 square roots of 28 minus square root of 32. Once again, I'm going to try and get a 7 there. And I've got 7 times 4. The 4 is a perfect square of 2 times 2. So this is 8 square roots of 7. This is going to be 4 square roots of 7 when we do 2 times 2. But now I need to try and break down the 32. 32 does not divide by 7, so I'm going to end up with an unlike term. But this is 2 times 16, and this is 4 times 4. I'm going to stop right there, guys. A lot of you want to break that down into primes, and you have too many pairs sometimes to keep track of. So stop as soon as you find a pair, and this is going to be 4 square roots of 2. So I'm going to combine these first two together. 8 minus 4 is 4 square roots of 7 minus 4 square roots of 2. All right, so that's what addition and subtraction looks like. We're now going to take a look at using the distributive property. So the distributive property is multiplying over addition and subtraction. And so that's what we're going to have to do. We're going to have to distribute, then try and simplify and combine like terms. So when we distribute, And we're doing square root of 5 times square root of 15. Because both of those are radicals, I can call that square root of 75. I then need to distribute square root of 5 to the 3. The 3 is not a radical, so I can't do 3 times 5. I simply write that as 3 square roots of 5. So the only time we can actually do the multiplication is when those values are both underneath the radical. So now we're going to try and break this down. I'd like to have a 5, so I'm going to start out with 5 and 15. But 15 breaks down into 5 and 3. So I don't end up with a 5 under my radical. I end up with a 3, and that's fine. We're going to pull out that pair of 5s, and we're going to call this 5 square roots of 3. This is already simplified. And even though there's no like terms, we did our distributing, and so that's our final answer. Now we have to distribute with 2 square roots of 8. So when we go to distribute that, once again, we're going to just multiply just like we did in number 3. I'm going to do outside times outside. I get 6, and then radical times radical, square root of 80. I'm then going to continue to distribute, and I'm going to multiply the same way. 2 times 4 is going to be 8, and then square root of 48. We're going to need to simplify these. So we're going to I'm going to start with 8 times 10. Here's 4 times 2, and 2 times 5. I've got a pair of 2's, and then here's my second pair of 2's. So when we take a look at that, outside of my radical, I have the 6 from the earlier multiplication. I have the 2 that I pulled out. I have a second 2 that I pulled out, and then 5 was by itself. When we take a look at this is going to give us 24 square roots of 5. Now I've got to do that again over here. I would love to have a 5 under here, but 5 does not divide into 48, but 4 does. I'm not going to break down that 4 because 12 has a 4 in it. So now I have a pair of 4's that I can bring together. And then I have that 3 by itself. So this is going to be plus 8 times 4 when we bring down the 8. And when we bring over that 4 from outside the radical, but then we still have 3 under there. 8 times 4 is 32 square roots of 3. I don't have the same number under the radical, so that's where my answer stops. We have to FOIL. We're going to be doing that again a couple of times in this chapter with FOILing. I've got 2 minus square roots of 3 squared. Remember, square means to multiply by itself. So we're going to take 2 minus the square root of 3, and we're going to multiply it by 2 minus the square root of 3. We're going to distribute and FOIL. So we have 2 times 2 is 4. We're going to distribute the 2 to the minus square root of 3. That 2 is not a radical, so it simply gets written out in front of the radical. 2 square roots of 3. I then have to distribute that second term. So I'm going to distribute that negative square root of 3 to 2. It's the same multiplication we just did, so we're going to write it the same way. Minus 2 square roots of 3. And then we're going to distribute here. A negative times a negative is a positive, and we're going to call this square roots of 9. So hopefully there's a few things that jump out at you that we need to do. We've got the 4. And then we can combine these together to call minus 4 square roots of 3. Remember, the radical stays the same. I'm just adding 2, or negative 2 and negative 2. But 9 is a perfect square, so I'm going to take the square root of that and get 3. Once we do that, you should notice something that we have a second set of like terms that we can combine. 4 plus 3 is 7. So we have 7 minus 4 square roots of 3. Now what we have is we have the same thing. We have distributing with that FOIL. But we've got numbers outside the radical, and we have numbers with the radical. So we're going to multiply outside times outside is 12. And then radical times radical gives me square root of 16. I need to distribute that 4 again, 4 squared to 2 again. So I'm going to have a positive 4, because there's nothing outside the radical here on the 5. But then I'm going to have square root of 10. I'm having trouble changing colors here, so we'll see if I can pull out a different pen. I'm going to distribute here. I have a negative. There's nothing outside the radical here, so this is just going to stay 3 from the first term. But then we're going to call that square roots of 24. And then I'm going to distribute here, and I have a negative, because a negative times a positive is a negative. We're going to call that square roots of 15. Now from there, we would need to try and simplify these. Sixteen is a perfect square. It's 4 times 4. So this is going to be 12 times 4. 10 is 5 and 2. And so nothing pairs up. So this is going to be plus 4 square roots of 10. 24 is going to be 4 times 6. We've got 2 times 2 and 2 times 3. So when I combine those together, I'm going to have minus 6. And then those get multiplied together. Square root of 6. And then 15 is 5 times 3. Because both of those are prime, it's just going to say minus square root of 15. So that's why we took time yesterday to practice simplifying these radicals. The one thing I didn't simplify is I should have done 4 times 12 right away, and that's 48. So when we take a look, we have no like terms at all. We have a non-radical, we have a whole number, we have a square root of 10, a square root of 6, and a square root of 15. So I'm simply going to write my answer in that order from left to right. So we have 48 plus 4 square roots of 10 minus 6 square roots of 6 minus square root of 15. All right, ladies and gentlemen, you have a couple of on your own. I'm hoping the sub can get up here and press pause. I'll wait a little bit. But then I'm going to work these out, and you can watch that when the sub hits play. All right, we've got 3 times 3 is 9. We have 3 times positive square roots of 5 is positive 3 square roots of 5. We're then going to distribute the negative square root of 5, so I'm kind of repeating that addition this time. But because it's a negative times a positive, it's negative 3 square roots of 5. And then we're going to distribute here, a negative times a positive is a negative, and we're going to call that square root of 25. Notice these cancel each other out because we have a positive and a negative, and then this is a perfect square of 5. So we have 9 minus 5, and our final answer here is 4. For D, this is example 3 that you guys got done doing, so you have to multiply the 1 plus square root of 6 by itself. So we're going to do 1 times 1 is 1. 1 times the square root of 6 is the square root of 6. Square root of 6 times 1 is the square root of 6. And now we're going to do square root of 6 times square root of 6. Because those are both under the radical, we actually multiply those together and get 36. Well, we're going to have 1 plus square root of 6 plus square root of 6. Keep in mind that there is a 1 in front of each of these. So when we add those together, we have 2 square roots of 6. Square root of 36 is a perfect square. So we're going to have plus 6. And now when we go through and combine like terms, we have 2 whole numbers to add together. So we have 7 plus 2 square roots of 6. Ladies and gentlemen, good luck and enjoy tonight's worksheet.